Joining, including welding, brazing, soldering, and adhesive bonding. These processes form a permanent joint between parts. Assembly, like the mechanical methods of the fastening parts together. Some of these methods allow for easy disassembly, while others do not. The welding is a joining process in which two or more parts are combined at their contacted surfaces by application of heat and/or pressure. This can be heat alone with no pressure applied, or a combination of heat and pressure, or by pressure alone with no external heat. In some welding processes, a filler material is added to facilitate the merging. The welding provides a permanent joint. Usually, the most economical way to join the parts in terms of the material usage and fabrication costs. The welding is important because it's not restricted to a factory environment. The limitations of the welding process are the manually welding are expensive in terms of the labor cost. Also, it utilizes high energy and are inherently dangerous. The welded part cannot be deassembled, and some quality defects may occur. The part surfaces in contact or close proximity that are being joined are known as the faying surfaces. And the welding, we are going to have a localized merging at the faying surfaces. Usually, they must have the same metal. However, some welding operations can be used to join dissimilar metals. Some 50 different types of welding processes have been catalogued by the American Welding Society. The welding processes can be categorized into fusion welding and the solid-state welding. In the fusion welding, the joining processes that melt the base metals. A filler metal is added to the molten pool to facilitate the process. If no filler metal is added in the welding, it's called the autogenous weld. In the solid-state weld, the joining processes in which the coalescence results from the application of the pressure alone or a combination of the heat and the pressure. If the heat is used, a temperature is below the melting temperature of the metals being welded. Usually, no filler metals is added in the solid-state welding. The example of the fusion welding, including the arc welding, where the melting of the metals is accomplished by the electrical arc. The resistance welding, where the melting is accomplished by heat from the resistance to an electrical current between the faying surfaces held together under pressure. In the oxy-fuel gas welding, the melting is accomplished by an oxy-fuel gas such as the acetylene. The diffusion welding is one of the solid-state welding processes. In this welding process, the coalescence is by the solid-state diffusion between the two surfaces held together under pressure at elevated temperature. Another example is the friction welding, where the coalescence by the heat of friction between the two surfaces. Finally, the ultrasonic welding, where the coalescence by the ultrasonic oscillating motion in the direction parallel to the contacting surfaces of two parts held together under pressure. Welding is inherently dangerous to human workers. The risk can be the high temperature of the molten metals. In the gas welding, we may have the fire hazard. And the electrical power welding, the hazard mainly is going to be the electrical shock. The ultraviolet radiation, spark, spatters of the molten metals, the smoke and the fumes are mainly related to the arc welding processes. The automation is possible in welding and is classified into three main types: the machine welding, the automatic welding, and the robotic welding. The automation in welding will result in higher productivity, better quality, and more safety for the workers. The junction of the edges or the surface of parts that have been joined by the welding are known as the weld joint. Two issues about the weld joints: the types of the joints and the types of the welds used to join the pieces that form the joints. The most five common types of the joints are the butt joint, the corner joint, the lap joint, the teeth joint, and the edge joint. Each of the preceding joints can be made by welding. Other joining processes can also be used for some of the joint types. There are differences between the joint type and the way it's welded. It's called the weld type. The first weld type is the fillet weld, used to fill the edges of the plates created by a corner, lap, and T-joints. Fillet metals used to provide the cross-section in the approximate shape of a right triangle. The most common weld type in the arc and oxyfuel welding is the fillet weld. It requires a minimum edge preparation before the welding process. The groove welds usually require part edges to be shaped into a groove to facilitate the weld penetration. The edge preparation increases the cost of the parts fabrication. The groove shapes include the square, the bevel, the V, the U, and the J. This can be done in single or double sides. The groove welds is most closely associated with the butt joints. In spot welds and seam weld, the fuse section between the surfaces of the two sheets or the plates can be done by the spot welding process or the seam welding process, usually used for the lap joints and closely associated with the resistance welding. The flange weld and the surfacing weld both require some prefabrication processes. The surfacing weld used not to join the parts, but to deposit the film metals onto the surface of the base part. And the other two types are the bulk weld and the slot weld. Fusion to achieve coalescence in the welding. So high density heat energy must be supplied to cause the localized melting of the base metals and the film metals if used. For metallurgical reasons, it is desirable to melt the metal with minimum energy but high heat densities. The power density is the power transferred to work per unit surface area. If power density is too low, the heat is conducted into work, so melting will never occur. If the power density is too high, a localized temperatures vaporize the metal in affected region. There's a particle range of values for the heat density within which the welding can be performed. The calculation of the power density can be simply applied by using the equation that the power density is equal to the power entering the surface divided by the surface area over which the energy is entering. The unit are going to be in watt per square millimeter. Different welding processes have a various range of the power density. Not all the input energy is used to melt the weld metal. First, we have the heat transfer efficiency, F1. which is the actual heat received by the workpiece divided by the total heat generated at the source. The melting efficiency, F2, is the proportion of the heat received at the work surface used for melting. The rest of the energy is conducted into the work metal. The cross-section of typical fusion welded joint is shown in the figure. In the figure A, we can see the principal zones in the joint. The typical fusion weld joints in which the film metal has been added consist of the fusion zone, the weld interface, the heat affected zone, and unaffected base metal zone. Each one of these areas has been subjected to a different temperature. Some of them has been phase changed from liquid to solid. Thus, the grain structure of every zone is different from the others. The heat affected zone is a metal has experienced a temperature below the melting point, but high enough to cause the microstructural changes in the solid metal. The chemical composition same as the base metal, but this region has been heat treated so that its properties and structure have been altered. Effects on the mechanical properties in the has is usually negative.